Okay, let's look at this vertical projectile motion question from November 2018. It says, in a competition, participants must attempt to throw a ball vertically upwards past a point T marked on a tall vertical pole. Point T is 3.7 meters above the ground. Point T may or may not be the highest point during the motion of the ball. One participant throws the ball vertically upwards at a velocity of 7.5 meters per second from a point that is 1.6 meters above the ground as shown in the diagram below. Ignore the effects of air resistance. So the ball's going to go up and then obviously it's going to come down again. In which direction is the net force acting on the ball while it moves past point T? So obviously if we're ignoring air resistance, the ball is a projectile. So what is the force acting on the ball for the whole duration of its motion? The only force acting on the ball is the gravitational force or the acceleration due to gravity. So the answer has to be downwards because the gravitational acceleration is always downwards. So the answer is downwards because the only force acting on the ball is the gravitational acceleration. Now it says, calculate the time taken by the ball to reach its highest point. So obviously there are only three things we need to remember about projectile motion. That the acceleration is always the acceleration due to gravity, which is 9.8 meters per second downwards. The second thing is that the ball displays symmetry of motion. And the third thing, that the velocity at maximum height will be 0. So the time taken by the ball to reach its highest point, that is the maximum height, where my velocity will be 0. So let's say up is positive to answer this question because all of these velocity, displacement, acceleration are all vectors, so we need a vector direction. So up is positive, VF is 0, VI was 7,5 and it's positive 7,5 because it's upwards. The acceleration due to gravity is downwards, so it is negative 9,8. So now you can see I've got the equations of motion down the bottom here. I'm going to use this first one because it's the simplest one. The final velocity is equal to the initial velocity plus the acceleration times the change in time, and we are trying to find the change in time. So my final velocity is going to be 0, my initial velocity is going to be 7.5, and then we're going to add in 9.8 times delta t, but obviously the 9.8 is downwards, so it is negative. So if you do algebra and put it in your calculator, you will end up with a delta t of 0.77 seconds. Okay, now it says, determine by means of a calculation whether the ball will pass point T or not. So what we should do here is we should find out where is maximum height. Is it above T or is it below T? So we need to find out how far the ball traveled between the hand and the top of the pole, or its maximum height, and see is that longer or shorter than 3.7 meters. So there are two ways to go about this. You can find this delta y displacement here and add it to the 1.6 and see if that's bigger than 3.7, or you could say 3,7 minus 1,6 is, what is that? It must be 2,1 meters. Okay, so the ball must go to a maximum height of greater than 2,1 meters. Okay, because 1,6 plus 2,1 will give you 3,7, and so if the ball's maximum height is greater than that, the ball will have passed point T. So if we look at all of the equations of motion, if we want maximum height, we know our VI is 7.5, and we know our VF is going to be 0, and we are looking for delta y. So you can use the delta t you found in the previous question, but I like to use formulas that only have things that are in the question. And if you can't do that, you use the answer from the previous question. But in this case, we can use the final velocity squared equals the initial velocity squared plus 2a delta y. Remember, we put the delta y in because the ball's going up. So the final velocity will be 0. The initial velocity will be 7.5 squared plus 2 times negative 9.8 because the acceleration is downwards times delta y. So if you put this into the equation and you do some maths, you get 56,25 is equal to negative 19,6 delta y, and then if you work that out, you get a delta y of 2,869 something. So it's 2,87 meters. So 2,87 meters is bigger than the 2,1 meters that the ball needed to travel. So answer the question, yes, the ball will pass point T. Okay, so that was actually quite easy. Now it says to you, draw a velocity time graph for the motion of the ball from the instant it is thrown upwards. Okay, so now first of all, let's think about our graphs. We have three graphs. We have a displacement time graph, and that one takes the shape of the ball's motion, more or less. It looks sort of like a thrown ball. We've got the velocity time graph, which is always a straight line because it has got uniform acceleration, and the gradient of the graph is the acceleration. So depending on which way up is positive or down is positive, depends on which way the gradient of the graph will go. So I'm going to choose to say up is positive. Okay, and the third graph that we haven't talked about is the acceleration time graph, and the acceleration time graph is always a straight line unless the ball comes into contact with another force. So let's draw our sketch graph. Label your axes: velocity in meters per second, time in seconds on the x-axis. So the velocity time graph, if up is positive, it says draw a velocity time graph for the motion of the ball from the moment it is thrown upwards until it reaches its highest point. Okay, so we don't want the ball's journey downwards, we want the ball to stop at its highest point, and we know that at its highest point the velocity of the ball will be 0. So if we just draw a line of a uniformly negative acceleration, that would be a nice straight line drawn with our ruler. The ball left the hand at 7.5 meters per second, and at its maximum height it was at a velocity of 0. And this time here we calculated in the first part of our question, this was 0,77. And that is all you will need for this graph, which is why it was only worth 2 marks. It's a very simple graph.